We are going to correct the building and ion worksheet. And as we go, I just want to highlight some of the reading. When we give the charge, technically it's supposed to be the number, then the minus. But I'm not going to get hung up on that, whether it's F1 minus or F minus 1. I want to say again that the electrons are found in the shells, and the shells are outside of the nucleus. Each shell can hold a certain number of electrons. The first one will hold 2, and each one after that will be 8. Now you will have some classes in the future that will change that up a little bit, but for me it's 2, 8, 8, 8, 8. So our happy number is 8. The electrons in the outermost shell are called valence electrons. Excuse me. And if we have more electrons, we have a negative charge. And if we have less electrons than protons, we have a positive charge. So let's do a couple of these, and I'll be switching back and forth between the periodic table. I got my periodic table up here. So lithium, the question is how many protons, how many neutrons does it have? So lithium is right here, and it is 4 and 7. So if we start with lithium, 4 and 7. How many protons does lithium have? Well, it has 4 protons. How many neutrons does it have? Well, this is protons plus neutrons. This is protons. So that means we have 3 neutrons. How many electrons in the first shell? Well, if we have 4 protons, that means we have 4 electrons. And the first shell has 2 because it can only hold 2. So if we have 4 and 2 are in the first shell, then that means 2 needs to be in the second shell. Will lithium gain or lose 2 electrons? Well, it's either going to gain or lose some number less than 4. So it is going to lose. And how many to empty or fill the outermost shell? It's going to lose 2. So if it loses 2 negative charges, that means that lithium then becomes lithium 2 plus. Okay. So next one is oxygen. And if we take a look at oxygen, oxygen is 8 and 16. So oxygen is 16 and 8. So how many protons will it have? It'll have 8. How many neutrons? 16 minus 8 is 8. How many electrons in the first shell? That'll be 2 because that's all it can hold. And of that 8, if we have 2 out, that means we have 6 in the second shell. And we need to get to 8 because once again it's 2, 8, 8. So we need to get to 8. So it is going to gain, and how many? It's going to gain 2. It's going to gain 2 negative charges. So oxygen gained 2 negative charges, so it will be oxygen 2 negative. Next one is chlorine. So if we take a look at chlorine, is right here, and it's 17 and 35. 17 and 35. So chlorine, 17 and 35. How many protons? 17. How many neutrons? That'll be 18. How many, so we have 17 electrons. So we have 2, 8, 8. So how many electrons in the first shell? That'll be 2. How many electrons in the second shell? That'll be 8 because it can only hold 8. And that takes us to 10. And we have 17, so our third shell will hold 7. So if it has 7 and it wants to get to 8, because either we gain 1 or lose 7, it wants to get to 8. So that means it's going to gain 1 negative electron, and chlorine will become a -1. Or I guess it should technically be 1 negative, but I'm not going to get hung up on that. Some people will just write that. Once again, I like putting the 1 in. just so we know that you have gone out of your way to answer that. So build the following: an ion with 4 protons. Okay, so it has 4 protons and 2 electrons. 4 protons gives us beryllium. So we have beryllium. So we have beryllium, and it has 4 positives and 2 negatives. So that means it has 2 more positives than negatives. So that means it'll be a 2 positive. And 9 protons, and I'm not going to switch back. I'm just going to look at my periodic table here. That is fluorine. So fluorine has 9 protons and 10 electrons. So it has 1 more negative electron than positives. So that means fluorine is going to be a 1 negative. An ion that has 16 neutrons, 15 protons. I switched them around on you. 15 protons give us phosphorus, P. So it has 15 protons, 15 positives, and 18 negatives. So that it means that it has 3 more negatives. So that'll give us a 3 negative. An ion with 12 neutrons, 10 electrons, 10 negatives, and 12 protons. 12 protons gives us magnesium. And I'm going to write over there just because I can write bigger. And it has 12 protons, 12 positives, and 10 negatives. So that means it has 2 more positives than negatives. By looking at the periodic table, try and answer the following questions. That's supposed to be type of charge will the following elements have in ionic form? So lithium has 3, so that means 2 in the first, 1 in the second. It's going to want to lose 1 negative electron, so that becomes a +1. Sodium has 11, 2 in the first, 8 in the second, and 1 in the third. So that means that we are going to lose 1, so it will have a +1 charge. And potassium is right underneath it. It will have a +1 charge. And rubidium is right underneath it, and it will have a +1 charge. So if we take a look at the periodic table, all of these in column 1 are going to have a +1. Now, if you notice, hydrogen is a different color. So it's really not in column 1, but lithium, sodium, potassium, rubidium, cesium, and francium, they all have 1 in the outermost shell, so they're going to want to lose 1. Well, let's take a look at the next one. Fluorine has 9. So if it has 9, that means 2 in the first and 7 in the second. So if it has 7 in the second, it wants to get to 8. So that means it's going to gain 1 negative electron. So it will have a -1 or 1 negative charge. Chlorine has 17. So that gives us 2, 8, and 7. So 7 wants to get to 8, so it's going to gain 1 negative electron. So fluorine is -1, and chlorine is -1, and bromine is right underneath it. It's going to be a -1 charge, and iodine is right underneath it, and it's going to have a -1 charge. So if we look at the periodic table, fluorine, chlorine, bromine, iodine, and astatine are all in group 17. And a lot of times you'll see a periodic table that will call it 7b. But all of these are in group 17 or group 7, and they're all going to want to gain 1 negative electron. So all of these will be a -1 charge. Oops, wrong button. Okay, beryllium and magnesium. Beryllium has 4. So that means 2 in the first, 2 in the second. It's going to want to lose 2 negative charges. So that means it'll become a 2 plus. Magnesium has 12. So 12 is 2 in the first, 8 in the second, and it has 2. So it's going to lose 2 to get to 0. So it will become a 2 plus. And calcium and strontium are right underneath it. So it will be a 2 plus, and it will be a 2 plus. So if we look at the periodic table again, so beryllium and magnesium, calcium and strontium, barium and radium are all in group 2. So that tells us they have 2 electrons in their outermost shell. So these are all going to end up with a plus 2 charge because they're going to lose 2 negative electrons. Okay. Then we have oxygen. Oxygen is 8. That's 2 in the first, 6 in the second. 6 is going to want to go to 8, so it's going to gain 2 negative electrons. So it will become a 2 negative. Oops. Sulfur is sitting with 16. That's 2 in the first, 8 in the second, and 6 in the third. 6 is going to want to go to 8, so it's going to gain 2 negative electrons. So it will be a negative electron, a negative 2 isotope. Selenium and tellurium are right underneath it, and they will become a negative 2 and a negative 2. So if we take a look at the periodic table, and if you have a paper periodic table, here's where you may want to jot some notes down. Okay, group 1 has 1 electron in their outermost shell, and it wants to lose 1 negative electron. So all of these will become a 1 plus. Over here, group 17 have 7 in its outermost shell, and they want to get to 8, so they're all going to gain 1 negative electron, so they will all be 1 negative. Group 2 has 2 electrons in its outermost shell, so it wants to lose 2 negatives, so it will become a plus 2. And then group 6 or 16 has 6 in its outermost shell, so it wants to gain 2 negative electrons to get to 8, so it will become a 2 negative. So as we take a look at these going up and down, they are called groups, families, or columns. And what they have in common is the number of electrons in their outermost shell. Now, we haven't talked about boron, but boron is in group 13 or 3. That's an R, not an F. So boron, aluminum, and gallium, all of these, for the most part, are going to want to lose 3 if they're going to lose. Likewise, nitrogen, phosphorus, arsenic, antimonium, and bismuth, they're going to want to gain 3 negatives, so they will become a negative 3. And in all honesty, these aren't going to, group 4 are not going to give or take. These in here are the transition metals, and we don't deal with them when it comes to bonding, because they're going to have metallic bondings. And when we talk about bondings, we talk about valence electrons, but we don't deal with those. You might deal with those in chemistry. So let's go back to the worksheet. And so groups, columns, or families go up and down on the periodic table. What do these elements, what do the elements in each group, column, or family have in common? And that is going to be the number of valence electrons. Okay, and that's how many they're either going to gain or lose. Rows go across the periodic table. What do these elements in each row have in common? And that is the outermost shell. And I'll explain that in just a second, but let's take a look at this. this last one. The elements in the last column have not been asked about. Can you explain or make a statement about what you think they will do with their electrons? So we're going to talk about rows and the last group. So rows go across. So if we take a look at row 1, they all use the first shell. Row 2 all uses the second shell. Row 3 starts filling the third. Row 4 starts filling the fourth, and so on. So rows are the number of shells that are being used. Groups, columns, or families are the number of valence electrons. Now let's take a look at this last group, group 8 or 18. Helium is a little bit different because it has 2, but it can only hold 2 in its first shell. So if we take a look at these, they're all full. So what do they want? They want nothing. They want nothing to do with really anything. They are technically, the name of the family is called the noble gases. And at one point in time, they were called the inert gases because they don't react with anybody. I like to think of noble as nobility. They're not going to call me to play cards or go out to eat. So that is the Build an Ion worksheet.